All right, you have already learned how to write in scientific notation, and you have learned how to multiply two numbers written in scientific notation. So in this lesson, we're going to go over just adding, subtracting, and dividing, so you actually have a good grasp on that. We're going to jump right into an example. So the key thing when you are adding or subtracting numbers written in scientific notation is they have to have the same 10 base to the power of their exponent. Their exponent has to be the same. So you're going to manipulate the number that's in the front, which is called the factor. I finally remembered that. I kept calling it coefficient. So that 4.6, that's called the factor. 8.72 is the other factor. So you'll rearrange sometimes to make that happen. But you can see in this first example, my 10 base exponent has the same exponent, so we can just move on and do the addition. So essentially, you're going to combine the factors into addition, because that's the arithmetic we're doing here. So you're going to do 4.6 plus 8.72 and put that in parentheses. And then that whole thing is times 10 to the third. Okay? So you're just going to add that. 4.6 plus 8.72. You add that together and you get 13.32. And then you just rewrite 10 to the 3, because originally they were both being multiplied times 10 to the 3. So after you've combined the factors, we only have to have one of the 10 to the 3. You're not actually going to add that 10 to the 3 to itself. It's just one of those. And then you see that this 13.32 is not completely written correctly in scientific notation. It has two numbers to the left of the decimal, so we're going to move the decimal to the left one more time and get 1.332 times 10 to the 1, because we moved it. Now you have two different exponents, so we're going to do 10 to the 1 times 10 to the 3. And when you do that, you just add the exponents and get 10 to the 4. All right, so this is how you deal with it. There's not on your owns for this. I might do one or two of your practice problems, but that's how you do addition. So let's look at the next example. All right, so example 2, make sure you have this in your journals. This is lesson 9.6b for the 8th graders and 13.6b for the 7th graders. All right, so this one is subtraction. We have 3.5 times 10 to the negative 2 minus 6.6 times 10 to the negative 3. First off, you notice right away that the exponents are not the same exponent. So when you're doing addition and subtraction, they have to be the same exponent. So the first thing we're going to do is rewrite one of these in order to make it have the same exponent. So we're going to rewrite the 6.6 times 10 to the negative 3 so that it will become 10 to the negative 2. So the 3.5 times 10 to the negative 2, you don't have to do anything with. You just kind of ignore it for a minute. So we're going to take that 6.6 times 10 to the negative 3. Well, how would I make that negative 3 a negative 2? Well, if I move my decimal, it will change. Oh, they're making it more complicated. You can see they just broke up the 10 to the negative 3 and 10 to the negative 1. You can do that if that helps you. I just want to know that I need one less of that negative 3. So I'm going to move my decimal to the left one more time and get 0.66. Now, this is not technically written very good scientific notation because you're supposed to have one number, but we're doing it this way so we can do the math and end up with the correct answer. So you get 0.66 because I grabbed my decimal, moved it to the left one more time to get rid of one of those negative exponents. And that means I have 10 to the negative 2. Now that I have 10 to the negative 2, it's the same exponent as the other, and I can do my subtraction. So I grab my factors, and you got to go left to right. So you're going to have 3.5 minus 0.66. It is important you keep these in order from left to right as far as the factors go. And then times 10 to the negative 2, which is what my new base power was. So 3.5 minus L9.6b gives you 2.84, and fortunately it didn't go above one number to the left, so that is your final answer. 2.84 times 10 to the negative 2. So, big thing to remember here is if they do not have the same exponents in addition or subtraction, you have to manipulate one of them so that it makes them both have the same exponent. Alright, I will do, this is your actual assignment, the practice numbers at the bottom of the page here, numbers 1 through 8. I will do number 1 with you. This is a free answer, so make sure you grab a 7-piece of paper. Number 1, and we're adding or subtracting, so we have 3 times 10 to the 7 plus 2.4 times 10 to the 7. Okay, so first thing I look at is, do these have the same exponent? Yes, they do. So now I can just rewrite. I'm going to say, here's the math that I'm doing, so I'm going to say 3 plus 2.4, and then that's going to be times 10 to the 7. My exponent was the same, so I didn't have to manipulate it at all. So now I just add my 3 plus 2.4, which is going to give me 5.4 times 10 to the 7. And I'm done because I only have one number to the left of my decimal here, so we're good. All right, there was number 1. I'm just going to look at these and see. I'm going to do one more that I have to manipulate, so that way you get used to that. Let's do number 7 together. I think that's one that's going to be a good one. So I have 1.1 times 10 to the 5th minus 4.3 times 10 to the 4th. Alright, so you see that this one, the exponents are different. So we are going to have to manipulate one of these to get the same exponent. Well, since this is subtraction, I would look at this and say, well, 1.1 minus 4.3 is going to give me a negative number, but if I change this exponent to a 4, that's going to make me move my decimal back one more, which makes my math nice and easy. So instead of having 1.1 times 10 to the 5th, if I move it back, I get 11 times 10 to the 4th. And then I just rewrite 4.3 times 10 to the 4th. So now I can deal with just my factors. So we have 11 minus 4.3 times 10 to the 4th. Well, 11 minus 4.3 should give you 6.7, and then you just finish it off. Luckily, we only have one number to the left of the decimal, so we're done. Alright, not too bad. So let's go back and look at my next example. Alright, so division with scientific notation. Nice thing about this, you don't have to manipulate a whole lot. We're just going to separate them into their like terms and do division, which you guys already know how to handle division with exponents. So let's go through this. This is example 3. Make sure you put it in your journals. So we're going to find 1.5 times 10 to the negative 8 divided by 6 times 10 to the 7th, and then rewrite it in scientific notation at the end. So the first thing you're going to do is kind of cut that in half, and you're going to do the left-hand factors division, and then on the right-hand side, you're going to do the exponent with the bases. So you can see I've cut it in half, 1.5 divided by 6, and then you say times, and then you do the 10 to the negative 8 divided by 10 to the 7th. So we'll do the left side first. 1.5 divided by 6, you should get 0.25, and we just rewrote 10 to the negative 8 times 10, divided by 10 to the 7th. So now, remembering when you divide base powers that are the same with exponents, you're going to subtract those exponents. Remember, when you multiply, you add the exponents. When we're dividing, we subtract the exponents. So I have negative 8 minus 7. So negative 8 minus 7 goes further negative to negative 15. So I just rewrite 0.25 times 10 to the negative 15. So then the last thing to look at is the fact that 0.25 does not have a number that is in front of the decimal. So I need to manipulate it one time, move the decimal to the right once. If you move it to the right once, that gives you 10 to the negative 1, because we moved to the right. So then you just combine that negative 1 and negative 5, which if you remember, you're now adding the exponent. So I get 2.5 times 10 to the negative 16. So that's on division. Okay, let's look at our last example. All right, so this is example 4. And this is a word problem. Why did my sun and earth? Let me see if they pop up. Nope, let me reload this. Well, there's supposed to be a picture of a sun. There's a sun right here, and then the earth is right here. But I guess they're not important for learning this. So, all right. So how many times greater is the diameter of the sun than the diameter of the earth? So we're going to divide the diameter of the sun by the diameter of the earth, because I want to know how many times greater it is. So you can see on the left, the sun is 1.4 times 10 to the 6th, and on the right, the earth is 1.28 times 10 to the 4th. So we're going to divide those. So again, you kind of chop it in half and move the factors on the left and then the base with your exponents on the right. So 1.4 divided by 1.28 gives you a nice, ugly long decimal, 1.09375. And then we're going to divide the 10 to the 6th by 10 to the 4th, which means you subtract those exponents, 6 minus 4, which gives you 2. So then this is 1.09375 times 10 to the 2. That would be written in scientific notation. Now, they're asking how many times greater is the diameter of the sun than the diameter of the earth. They actually want the number, so they don't want it in scientific notation. I probably wouldn't have counted off if you left it in scientific notation, but you would move it back to standard form, which you remember. Positive 2 on the exponent means we're going to move the decimal to the right. So you're going to get 109.375. So the diameter of the sun is about 109 times greater than the diameter of the earth. All right. Let me take a look. All right, so we've already done 2 of these, number 1 and 7, but I still want you to finish the rest. So these are the practice problems, and you need to do all of them, numbers 1 through 13, so just 13 problems. You've already done number 1 and 7. Number 13 is the only one that you will not write in scientific notation. That's like our last example. So you're going to solve it and then tell me it's about this many times greater. It's another diameter. Oh, no, another thickness thing. So that's it. Short assignment today. Let me know if you have any problems.